Okay, class. I just wanted to go over the stretch challenges for the team activity for week 7, and just to give me a chance to talk a little bit about pointers. A lot of people have had some trouble, and it's always a hard concept to be able to wrap your brain around this whole pointer thing. So here's the instructor's solution, and I've added some stuff to it for the stretch challenges. The activity was supposed to help you refresh your mind and get used to using pointers again. Okay, so if we went into main, you can see from the activity, and remember that we created a dynamic array of floating point numbers. Okay, so we use the new character to create it dynamically, and you'll notice that we say to declare the type for this variable, it is a float with a star. That means we're creating a pointer. So we use a pointer for an array because all an array is just a pointer to the first item in a bunch of values that are all together in memory. So this array is just going to be a bunch of floating point numbers that are all going to be in the same area in memory, all next to each other, real close together, and their addresses will just be incremented. So what a pointer really is a pointer is just an address to a place in memory. Okay, so what this is saying is, okay, I'm going to store the address of the first place in memory where a bunch of floats are standing next together. Okay, next to each other. And so if you can get to the first float and you know that they're all next to each other, you can just increment the address and you can look at every single item in the array. That's the whole concept of an array. But it relies on a pointer to the first element. So you can either, when you output an array, you can either say, okay, just index it based on a position, or you can do a little array, pointer arithmetic and just add one, or add one to the address to find the next item in the array. So you can do that either way. So hopefully you figured that out from the activity. But on to the stretch challenges. The stretch challenge in the first one, it asks you to, I'm just going to comment out some stuff so I can talk about it as we go here. There we go, okay. In the first part of the stretch challenge, it wants you to dynamically allocate an array of float pointers. So this is just a little bit different than what you did in the activity. In the activity, you created an array of floats, actual values. In this one, we're creating an array of pointers to floats. Okay, so when we look at line 95 here, we have 2 asterisks to be able to define this. The first one defines that it's a floating point and it's a pointer to a floating point. Okay, that will be the pointer that points to the first element in the array. The second asterisk is saying, oh, I'm sorry, I got those backwards. The first one is saying that we're storing pointers to floats. The second asterisk is saying, okay, this is the pointer that points to the first element in the array. Sorry, I had those backwards. All right, and then we use the new operator and we create a new array of type floating point, pointer, and we give it an array size. So in other words, we're storing addresses in our array. And every one of those addresses is going to point to one of the floating point values in the original array. So to make them point to those, we have to grab the address from the original array. So the original array was called P array. our new array is float pointers array. Okay. So for each item in the new array, we're going to set it equal to the address of the original array at the same position I. So this ampersand, what that does is you put that in front of any value, like a floating point value or an integer value. In this case, it's floating point. You put that in front of a value, and it will give you the address to where that value is stored. So each time through the loop here, my array of pointers is going to restore an address that points to a value. So now I have an array of pointers. And if I printed that array, or output it, I'll use the function from the activity, get value from pointer. All I have to do is give it the next item in my float pointers array, because they're all addresses, they're pointers. And it should show me the value that it's pointing to. If I run that, floating point value, 1.1, 2.2, 3.3. Okay, so my array of pointers are all pointing to those values from the original array. Very good. Okay, the next challenge was swapping. Oops, wrong way. There we go. All right. So I defined a function called swap elements, and we're going to send it our array of pointers, and we're going to try to swap the first and the last position in those pointers. Okay, but we're going to swap the addresses in my new array, and that shouldn't affect the original array that it's pointing to. Let's look at the swap function. Swap elements. All right. So it gets my array of pointers, and it gets a position A and position B. We're going to temporarily store the first address in a floating point pointer so that we don't lose this value. Then we replace the value at position A with the value at position B. Both of those are addresses. We're just swapping the addresses. Then position B, we will change that one, we'll override that one with the value we put into the temporary variable. Okay, so now at position A, it should have the address that was at position B, and position B should have the address that was at position A. Swap the addresses, so it didn't touch the original array. Swap. All right, so after I call swap, I'm trying to swap the beginning and the end. I'll look at the pointer array, and then I'll look at the original array to make sure it didn't change. Let's make it smaller this time. 1, 2, 3, 4, 5. Okay. So the pointer array got swapped. So the connections got all twisted up, but the original array stayed the same. Okay, and the third part of the stretch challenge, open that up, is actually applying a little sorting algorithm using the swap function to swap elements when it finds things out of order. So I defined a sort array function. I pass it the array of pointers, and I made it so it sends it the size too, so I don't have to worry about that. And it's going to take my array of pointers, or the array of addresses that I'm storing, and it's going to put them in order based on the value they're pointing to. Okay, so when I print out the values that they're pointing to, that they would be in order. But all this, I can switch around those addresses without affecting the original array of floating point values. So after I sort it, I'll see if I've changed the original, and then I'll see what the pointer array still looks like. Okay, let's look at sort. Let's see if we can see this whole function. Okay, so the sort function, it takes a pointer to an array, good, and the array size, very good. All right, so the algorithm I have here is right here. The other stuff is just printing it out each time for testing. So the idea is I'm going to keep sorting this until my flag that says it's sorted comes on. So I'm going to start with a Boolean variable called sorted and set it equal to false. And while sorted is not true, I'm going to keep trying to swap things until I can get them in the right order. So I'm going to be optimistic at the beginning of the while loop and say, okay, I bet it's already sorted. So I'll say, okay, sorted equals true. Then I'll jump into a for loop. I'm going to run all the way through the array. Okay, this is not the most optimal algorithm in the world. I'm going to keep going all the way through the array lots of times. I'm going to go all the way through the array, and I'm going to do a test. I'm going to say if the value at this address points to is greater than the address that the next address on the list on the array points to. If it's greater, I know they're out of order, and I have to swap them. So I call that swap function. And if I'm going through this loop and I go through and I've swapped even once, then I know it's probably not in order, and I'll have to check again later. So I set sorted equal to false. Okay, it's going to go through every item in the array one at a time, and it's going to test it to the item next to it. So that's what this means. I plus 1. It's going to look at the position it's at, and it's going to look at the next position and compare them. If the left side is greater, we have to swap them, and then it'll move on to the next number. And so numbers will just keep getting swapped until the array's in order. Now this syntax might be tricky to you. Putting the star in front of something, remember, just says, hey, I would like to see the value that is at this address. So we call this dereferencing. So putting a star in front of a pointer says, go tell me what the value is at this address. So I'm doing that with both of these. What's the value at this address? Compare it with the value at the next address. Okay, now it's a simple algorithm, but it should work. Now this testing loop, I'm going through and I'm going to print out the entire array each time I do a swap, or each time I go through and swap all the way through once, so I can see what happens to the array at each step, just for a visual of what's going on. Okay, so down here where I call swap, it'll go through and swap. All right, let's just run it and see what happens. I'm going to do 10 of them, so I'll just put them out of order. 3, 4, 1, 6, 5, 2, 8, 7, 9, and 10. All right, so the original array is still intact, all out of order. And now I've started the sorting process, and it prints out the array once. I just have a C in so that I can control each step. All right, first time through the loop, the 4 got swapped until it hit the 5. And the 8 got swapped a ways, the 9 got swapped, more things got swapped, the 5 got swapped again, the 8 got swapped a little bit farther. Okay, and they're almost in order. The 3's coming down, the 5's going to get swapped, 4's going to get swapped, and now they're in order. It made it through, and it'll check it one more time, and it's all in order. All right, so the original array stayed out of order, but the array of pointers, we put those in sorted order based on what numbers they were pointing to. Okay, I hope that helps a little bit. And then don't forget to delete your array at the end. All right. Have a great week. I hope that helps a little bit understanding pointers. Just remember, pointers are addresses that point to somewhere where a value is stored. If you have a pointer, you can put a star in front of it to check what the value is. It's called dereferencing. If you have a value, you can put an ampersand in front of it to know what the address is, to store that into a pointer. Okay? It's a hard concept. You'll eventually understand it. Have a great week.